Go to the computer. Maybe we should have a new award for the end of this unit to be like, who's the sharpest recorder? Like looking out for the little details. Little details. All right, I'm recording now. Yeah, pause recording. All right, cool. So we'll just kind of briefly talk about define a server. We'll kind of diagram. It's already kind of diagrammed this response request cycle. We'll describe the different parts of a URL because that's how we're going to get access to different resources on the server. And you've all seen URLs constantly as you're browsing the web. And after the /, these paths change constantly depending on the resource being the page or the thing you're looking at. If you are just looking at taken to an image or something, that's URL is kind of indicative of what you're asking the server for. We'll explain Node, why it's useful in this process. Node is just one particular web server. It's one of many web servers. The other one we'll learn later on will be Rails. That's also another web server. Diagram how the internet works. Explain DNS. Just briefly kind of go over DNS. Anyone who's had a router at home, whatever your service provider, you probably had an issue at some point in time. And they're like, go over to the machine, open up your terminal and type this in there. And what do you see? Some of those numbers. Some of that information is key to you accessing the internet. DNS is key to that. And then we'll just kind of briefly talk about how packets, what are packets? Now they travel to servers. So what is a server? So conceptually, a server is just a computer that's turned on and connected to the internet. That's it. A server entails also that you must be providing a service, right? We have web servers. We have mail servers. We have, I don't think a lot of people use them anymore, FTP servers, file servers. So there's lots of services that are being provided on the web, and servers are the instrument by which delivers those requests, listens and delivers those requests. So normally, we're clients. For the most part, you have been up to this point in time a client. The only time I would say maybe you turned yourself into a server is maybe during Project One, you spun up a local server. I know I helped a few people work through that. I think Aaron had done that, right? So you actually turned your machine into a server, which meant that you were listening for requests on a URL. And so a client can be a server and a server can be a client. But in general, at one point in time, if you're asking for information, you are the client. And if you are providing the information, then you are the server. And this whole request response, like this request response here, is something that you're going to see later when we jump into Express. Because Express needs to take in a request sent by the user, and there's going to have information in that request, and needs to deliver a response. And these two are actually objects, unique objects that come in or get packaged by the Express tool. Now, when we do request information, once again, you do this all the time. It's just kind of like pulling the curtain back so that I can explain and describe some of the key terms being used here. When you add data, right? So if you ever commented on a LinkedIn post or Facebook or Twittered or did anything that involved you giving your information to the web in one way, shape, or form, you posted something. And these verbs, these kind of verbs here, get, post, get, put, patch, and delete, they're capitalized for syntactic reasons. Right? I mean, I could have just had a uppercase P and a lowercase OST, but what you're going to see is these verbs are most of the time syntactically uppercase because they represent something, okay? And they don't just represent the word post, they represent the verb post within an HTTP request, okay? So when you make a request, you're getting information back. And so post is one of those verbs. And so we create data. Get is your getting data. And you did that all the time. A lot of you, I'm going to say almost everyone used $Ajax, right? Everyone did. I don't know if I saw anyone using $.get, right? I don't believe I saw that. But once we get into this world of like using these definitions, didn't give me what I was looking for, jQuery. jQuery. Here's jQuery. I'm going to go to W3 Schools, right? So here, $.get. Get is the verb. When you used just Ajax, you opened the door to use any one of those four methods. Get, post, put, delete, any one of those. But when you use get, you're telling jQuery, like, I just want to get. That's the action that I want to do. I'm not giving any data. I'm not deleting any data. I'm not manipulating data. I'm just getting. And in that same context, if we had get here, we should, I don't know if this page is going to have the additional methods, but I believe we should have a delete as well. Maybe they do have a delete here. Let me see. Delete, right? jQuery, $delete, put delete. I don't actually know if they have a $delete. I thought they would, but here's just going to show us like delete requests. So they'll have the get, and then you use Ajax to do the additional deletes and the post methods, okay? And we saw that with, when you were looking at Ajax, you used get. So we have put and patch also, and delete. Put and patch is just updating data, okay? Sometimes you can update just a line of the data, just a certain portion of the data. Imagine you were giving an object, and that object had like 4 unique pieces of information, yet you were only updating one piece of that information. I think patch patches it, and it just grabs that one piece and updates the one piece, and put just overwrites the whole object. So it takes all of the previous information that you had and the one piece, like say you were editing a form, and that form you already filled out, right? And so you're like, hey, I want to edit my profile. So your profile shows you all of your profile information already, and you just edit like your nickname or something. What put would do is grab all the information and just kind of send it to the server and rewrite it, versus patch is like, oh, they just needed nickname updated, grab just that, send just that, and update it. And then there's delete, right? Delete would just destroy that piece of information. So based on these verbs, a lot of this stuff happens under the hood. So the get is the thing you used since the minute you turned on your first computer and got access to the browser. You were using gets. That's the thing that you've been using. So under the hood here, there is a natural get method running. But the basic breakdown, I'm just going to zoom in a little bit. The basic breakdown of the web is this. We start with a protocol, okay? And a protocol is just a language. Think of it no different as speaking Spanish versus speaking Chinese versus speaking Russian. There's in there, there's words, there's nouns, and there's verbs, and there's pronouns, and there's all this way of conjugating sentences together and sentences into paragraph, right? The normal language concepts. But each one does it very differently, okay? And so a protocol is how that particular thing, this protocol being HTTP, is speaking back and forth between the two servers, which essentially means if I'm talking HTTP, then I need Yashira to be talking HTTP. Otherwise, we can't have a conversation. If all Yashira understands is FTP or SMTP, and that's the language, then when we try to communicate, it's like, you're not really sending me the information in the way that I understand it. I'm expecting this, and you're giving me that, and I don't really know what to do with it, right? So both servers need to be speaking in this communication, and we do it. We're telling the server, I want to use the HTTP protocol, and the server's like listening on HTTP, like, all right, all HTTP comes this way. And then, so we decide on the protocol, and then we just give it an address, right? Like we start with this saying, this is the host or domain address. And we know like later on, we'll be pushing you to buy your own domain name, right? And so your domain name is going to be something like whatever this is. Here's example.org. I bought jkeohan.com. I could have bought jqhan.us or jqhan.io. All of these other ones are just offshoots now of the original kind of .com. There's servers that actually listen for org requests and com requests. And so this is the name you purchase. And www at times could be a web server itself. Like there is a web server in the example domain that is called www. It could be one server or it could be 100 servers massed together. And they just kind of like take turns between listening. Oh, you grab the first request. I'm going to grab the second request. This guy's going to grab the third request. That's going to grab the next request. So you could pool the web servers together. So that's could be a web server. But this here is pointing us someplace very specific. Now we're talking ports. When I did say that HTTP, the server is listening on a specific port, and that port is just a number that we can listen to on the server, and services bind to certain ports. That's what they do. So if a HTTP server is listening on the server, then you can guarantee that it is kind of like melded with a port. And like they are connected until you turn the server off and you reboot it, it'll bind back to that port. Okay, one service per port is the general concept, unless you have some sort of other service that's allowing it to like listen and then divvy up those requests internally to the server. It's usually one protocol for one port. That's the relationship there. And then we have the path. What is the resource that you want to access, really? And consider this like this path right here. You see how it's hello/world/food.html, right? Think of that no different than you creating your folder structure on your Mac, right? If I have a folder structure, that folder structure is going to have a parent folder, then /, and it's going to have this. No different than kind of like what we're doing here, right? / this folder, / this folder, / the actual resource that we want, right? So what we're doing here is we're creating that kind of elevated structure. It may not actually be a hello folder on the server. That may not actually exist. There may not be a world folder, but we're saying this is the path to the thing that we want. Most of the time it is. Most of the time you are going to have these folders. Okay, so we need to tell it how to get to the resource that we're looking for. Foo HTML is what we're looking for, and foo lives in this resource and that resource. And then we have query strings, because sometimes, and we all do this, anytime you do a Google search, you're in Amazon and you're searching, you get this additional, I want to look for this thing, and then all of a sudden, you see this question mark. And the question mark is like, I know you're looking in here, but you want to look for something, or you're querying something, right? So the $ means, hey, this is a query string, and you break that query string into like the keyword that you're looking for, and then the value. And so the server grabs that information. It's like, all right, they want foo.com HTML. Oh, wait, they also want to find something very specific. So I'm going to look through the resource that we have, and I'm going to look for things that have foo, and I'm going to see if their value is bar. And then I'm going to look for things that are baz and see if their value is bat. And if they both are there, I will return it, okay? And then we just have this hashtag fragment as well, just another way of kind of trying to see that particular resource. And the hashtag fragment itself is a URL fragment generally used by the client to identify some portion of the content in the response, okay? A broken hash will not break the link. You will see this. We're not going to be actually using this too often. I think maybe someone, I thought when we were presenting projects, someone mentioned hash routing or something like that as part of their URL construct. Did anyone mention that? Or am I just thinking out loud?
I used it in mine.
You did, right? Okay, I did remember someone mentioning it, that it was being used, right? So most of you did not. So one of the 25 used it. So it's not this thing that's used all the time, but it is, okay? And this kind of protocol, let me just see if I have it running on my machine. I just want to see if I install this extension. I don't see my extension there. So HTTP headers. Here we go. Here's headers. Do I have it here? I'm going to try to see if I have it open. I'm going to open it up. This is tool. Details. It is started. I don't see it here. Here. Oh, here's headers. All right. So I just have this tool. You don't have to install it. It's this tool that allows me to see, won't allow me to see this. So I'm going to go back here. And it allows me to see the request. Can everyone see that? I mean, it's kind of small. But you see this as it's a GET request. And then it has the IP. It has the URL to the actual resource that we're getting. You see how the status says HTTP 200. Okay. Right? So this is what's happening under the hood. My client, my browser, is asking to get this resource. That's the request. And then I get a response. And the status is like, hey, everything is good. 200, okay, is good. I think for when I was working through some of the errors with my squad, I slacked out something that had dog HTTP errors. And so it explained these response codes as like little dog pictures. But what I don't want to delve into this too much. I'm just kind of showing you an overview of what we will see later in regards to request and response. That same cycle that I showed you in the image, this is the request and the response cycle. Okay, and there's a lot of information. This is like, hey, I'm going to do this. I can do this. I can support that. And then the header's like, I can support this. I can do this. I take this content type. Hey, we agree? Great. Give me the resource. And so there's an agreement here that happens under the server. Nothing that you right now would be doing. I rarely have to go into that. And then what is Node? You've been working with Node up to this point, right? We've all spun up our servers using Node, the name of the server. So we kind of understand what that is. I don't feel like we have to go into it, but Node ultimately is going to allow us to spin up a web server and then keep that web server running and listening on a particular port. So I'm not going to go through this video. I would suggest maybe on break or something you watch it. It's a really cute video. It kind of walks through the internet and what makes up the internet and how it's connected. It's a great backstory. You know, as a developer, you're going to have to understand like what an IP address is and how you get. You'll see the IP address, but for the most part, it's not something that you spend a lot of your time doing. Okay, so I'll put that off because I really want to jump into Express, and that's where you'll get the full effect of everything. I did mention like there are HTTP status codes. You know, when the request or response are made, there's headers. The headers are the agreements. Hey, what do we agree upon? You're the server, I'm the client. I would like to speak using this protocol, HTTP, but even there, I would like, hey, are the zip type files that I can support as the server is gzip? And then the client's like, oh, I can support .zip and gzip, so let's just go with gzips, and you can support it too. So the headers have information like that and agreed upon, some agreed upon statements. And then the body is what you're sending, the actual data, right? You saw here when I did this, we saw that these were the request and response, and we don't have the body here. It doesn't go that far into the body. It's just, this is just HTTP headers. That's the actual tool. It's not HTTP body, it's headers. So you're just looking at header information, but this is the body. Everything that we sent is here, okay? And so when we do this request and response, we have things like, I accept certain things. Hey, what's the date? What's the host or the name of the host? Okay, so this is information, once again, that they just kind of agree upon. There is, let me see, a complete list here of all of them on Wikipedia. You can go here and take a look at all of the values that they do accept. Some of them you will work with once or twice. I don't work with them a lot, but there are things like content type is something that I've had to set as well. So there will be a few things here that you will set. Not too many of them. And then we have the body that has everything. Express here is something that is going to be our web server. Okay, Express is our web server, and it's going to be handling this request and response. And we'll go through that shortly. Okay, explain what DNS is. So DNS, super, super important. The internet runs on, or the resources that we actually access are done using, let me see if I open this up, an IP address. This is pretty kind of technical here, right? This looks like what the F is going on. There's a lot of stuff there. Let me break it down like this, though. And I'm just going to break it down even TCP IP model. All right. So I was looking at this. I used to, I don't know, 10 years ago plus, I used to teach like Network Plus. I was studying routers. I supported Microsoft, used to have servers and routers. And so I had to really kind of master this particular model. And this model, this TCP IP model, is what makes up the web, the protocols that are the foundation of the web as you know it, okay? IP address is run down here, okay? The physical layer is this. These are the bits, right? Here's the wire. I'm using a Cat5, Cat6. I'm using fiber. I'm using wireless. This is the physical medium by which the bits are transmitted. And then you move up one level to the actual location that I'm sending those bits. Like, where do you want to send them? Well, I want to send them to this address. This is the address that we're sending it. Everything that is connected to this web has an address because we need to know how to send it. It's just like if you want to send a letter to someone in the United States, you need their address. If there's an address, we can get the letter to that particular person. So this is the address. And then that address, because the address is so kind of convoluted, if you didn't know your friends as their names, right? So I'm just looking at Molly. So I was like, oh, I know Molly Stone. And they're like, oh, that's great. But what if people reference Molly as 10.5.7.3? And you're like, I'm not going to remember. If I met Molly and she was like, hi, I'm 10.3.7.21. I'm like, pleasure to meet you. And then Aaron jumps in. He's like, oh, I'm 172.3.5.1. I'm lost already. Yeah, I don't know who's who anymore. I don't know what numbers. You just threw a bunch of numbers at me. Our brains don't really understand those numbers in those patterns. We don't hold on to them. What we hold on to is a name. So I would remember Molly Stone. I would remember Aaron. I would remember them based on their names, because that's how we perceive things, right? So this IP address is those numbers of the address, and then we have to convert those numbers into something that we can type in, okay? And that's where DNS comes